Hello students. So today I am doing class for class 12 science. The topic is the determinant. So in the last class also we were doing the same topic, that is determinant. So today also I am continuing the same topic, that is determinant. So now in the last class we did question number 12. So now we will continue this question number 13. So in question number 13 you have to prove that. So this is the question, prove that. So question number 13 is you have to prove this determinant is equal to x minus 1 whole cube, right? So here the determinant is in the first row 3x square, 3x1, second row x square plus 2x, first element, second element 2x plus 1, third element 1. So what is the third row? First element 2x plus 1, second element x plus 2, and the third element is 1. Okay, so you prove LHS is equal to RHS. So now let us write down this left hand side, that is given determinant, that is D is equal to, again this determinant is written out here. Okay, so now here we see that there are 3 ones in the third column. So what is the method now? You can make any two of these ones 0 by using the property, that is property number 5, right? So let us use property number 5. So how can you make any two of these ones 0? So you have to write R1 minus R2, 1 minus 1, 0. R2 minus R3, 1 minus 1, 0, right? That means row 1 and row 2 are changing. So R1 dash is equal to R1 minus R2 and R2 dash is equal to R2 minus R3. That means row 1 and row 2 are changing, right? So D is equal to, now what is the determinant now? Now R1 minus R2. So row 1 is changing, new row 1. So R1 minus R2, 3x square minus x square minus 2x. What is 3x square minus x square? That is your 2x square. Then minus 2x. Then you should write minus 2x, right? Then comes, then what? 3x minus 2x minus 1. 3x minus 2x, x. Then plus into minus minus, that is 1, right? Next, what is R1 dash is equal to R1 minus R2, that is 1 minus 1 is, this is also 0. This is 0, right? So this is the new first row. Now row 2 is also changing. So how does it change? So R2 dash is equal to R2 minus R3. That means this minus this. X square plus 2x minus 2x, 2x gets cancels. Minus into plus minus 1. That means x square minus 1, right? So this is your x square minus 1. Next, again R2 dash is equal to R2 minus R3. We are using here R2 minus R3. So we get there x square minus 1. This 2x gets cancels, right? Next, again R2 dash is equal to R2 minus R3. 2x plus 1 minus x minus 2. That is 2x minus x is x. Then plus 1 minus 2 minus 1, right? Next, what is 1 minus 1? That is 0. Is that clear? So this is your new second row. So third row remains same. That is, what is the third row? Write down. You can copy it. That is 2x plus 1. This is 2x plus 1. Then x plus 2. Then it is 1. Right? So now you can simplify some particular terms there. That is 2x square minus 2x. 2x is common. X square minus 1. That is a square minus b square. That is, you know that it is a plus b into a minus b, right? So therefore D is equal to, you can simplify this first term. In the first column, what is common there? 2x. So it is x minus 1, right? Then here a square minus b square form a plus b into a minus b. A plus b into a minus b, right? X plus 1 into x minus 1. Then this is 2x plus 1, right? Now second column remains same here now. X minus 1, it is x plus 2. Then third column also remains same. That is 0, 0, 1. Right? So now what will you do in the next step? So you can take common here. So from the first row, what is taken common? X minus 1. From the second row, again x minus 1 is common out there. So you can take x minus 1 whole square. From the first row, x minus 1 is taken common. From the second row also x minus 1 is taken common. So x minus 1 into x minus 1 is x minus 1 whole square, right? So now what is the first row here now? It is 2x, right? This is 1 and this is 0, right? Second row, from the second row also x minus 1 is taken common. So it is x plus 1, this is 1 and this is 0. Third row remains same, that is 2x plus 1, right? Then x plus 2, then 1. Okay? So now again you have to simplify this determinant. Now, what will you do with this determinant? Now there are 2 zeros in the third column. So you can expand it. You can expand it with respect to this third column, right? So therefore D is equal to x minus 1 whole square. Let us expand it. So how can you expand it? First column plus minus plus, second column minus plus minus, third column plus minus plus. Now plus 0 comes first. Will you write plus 0? No, because 0 into any number is always 0. Then comes minus 0. Here also 0 into any number is always 0. Then comes plus 1. But you have to write this one, right? So 1. So within second bracket. If you consider this one, delete the row and the column through this element. That means forget about the third row and the third column. So the remaining terms are 2x1, x plus 1, 1. This is the second order determinant. You know how to expand it, isn't it? So 2x multiplied by 1. That is 2x. Then minus sign. There is a rule. You should write minus sign there. What is x plus 1 into 1? X plus 1. But because of this minus, sign changes. That is minus x minus 2 plus minus 1. Right? So we got this expansion. That is 2x minus x minus 1. This is the expansion of this determinant. Okay? So therefore D is equal to x minus 1 whole square into within bracket. What is 2x minus x plus x? That is x minus 1, or D is equal to, what is x minus 1 whole square into x minus 1? If these two x minus 1 are added, if these two x minus 1 are multiplied, if x minus 1 and x minus 1 are multiplied, the powers will be added. There is 2, this is 1, 2 plus 1 is 3. So x minus 1 whole cube. That means which is equal to right hand side. So we proved it. Okay? So this is the answer. So I think you have understood it. So you can copy it. That is the next question. That is question number 14. Okay? So now we are doing question number 14. This is also prove that. So here the determinant, given determinant is this one. You have to prove this determinant is equal to RHS. That is 2 into x plus y into y plus z into z plus x. So here the determinant is x plus y plus z minus y. First row. Minus z, x plus y plus z minus x. Third row, minus y minus z, x plus y plus z. You have to prove this result. Okay. So what is D in this case? It is x plus y plus z minus y minus z, x plus y plus z minus x minus y minus x, and this is your x plus y plus z, right? So now you have to consider the right hand side also. You have to prove in each factor this is the sum of two terms. That is in the first factor x plus y, second factor y plus z, and what is the third factor? It is z plus x. So what will you do here to get all these terms, that is x plus y plus z, and z plus x, right? So let us check it. So if you do r1 plus r2, okay, z gets cancelled, you'll get x plus y, right? This plus this, z gets cancelled, x plus y. Is that clear? So here also minus z, that is minus is taken common, this is x plus y. That means we are taking the same element, that is x plus y, in the first row, right? So similarly r2 plus r3. Let's do r2 plus r3. Minus z minus y. Minus is taken common, y plus z, right? This plus this, x is cancelled, y plus z. This plus this, again x gets cancelled, you will get y plus z here also. So in the second row, we are getting y plus z as common, isn't it? So you can take it outside, right? So we are getting the two factors here, x plus y as well as y plus z, by using the property r1 dash is equal to r1 plus r2 and r2 dash is equal to r2 plus r3. Is that clear? So now let's do this property. So r1 dash is equal to r1 plus r2 and r2 dash is equal to r2 plus r3. You may do column wise also. You may do in column wise also. That is c1 plus c2, z cancels, x plus y. Here also z cancels, this is also x plus y. Here minus y minus x, that is minus is taken common, you will get x plus y, right? So this is the new first column. You can take common x plus y outside determinant, right? So this is also second column plus third column. That is minus z minus y. Minus is taken common here, y plus z. Here x is cancelled, this is also y plus z. Here also, if you add these two, x gets cancelled, you get y plus z, right? So from this second column also, we can take that common y plus z outside determinant. Is it clear now? So you can use the property either in terms of rows or in terms of columns. But we are using here in terms of rows. So you may practice it at home using column, right? So now let's do r1 dash and r2 dash. So therefore d is equal to, now this is r1 dash means row 1 is changing. How does it change? X plus y plus z minus z, that is x plus y. This is x plus y. Next r1 plus r2, that is this plus this, z gets cancelled, you get x plus y. Next one is, what is the next one? Minus x minus y, isn't it? Or minus y minus x. Here minus is taken common. So it is x plus y. Is that clear? Next, now row 2 is changing. How does it change? R2 plus R3 now. This plus this. Again, this is minus z minus y. Minus is common here. Y plus z, right? Again, this plus this, x gets cancelled. You get y plus z. This is y plus z. Again, minus x plus x gets cancelled. You get y plus z. So this is your y plus z. Is it clear? So this is the new second row. So now third row remains same, right? So minus y, minus x, and x plus y plus z. And it is x plus y plus z. I think you have understood it. Okay. Now what will you do in the next step? Now we can take common. From the first row, x plus y is taken common. From the second row, y plus z is taken common. That is x plus y into y plus z. We are getting these two terms, which is on the right hand side, isn't it? That is x plus y, y plus z, right? So therefore, d is equal to x plus y into y plus z, right? What is the first row? First row will be 1, 1 minus 1, isn't it? It is 1, 1 minus 1, right? Now from the second row, y plus z is taken common, so it is minus 1, this is 1, and this is what? 1, right? Next, third row remains same. Minus y, minus x, this is x plus y plus z. So from the first row and the second row, respectively, x plus y and y plus z are taken common here. Okay? So now what will you do? Again you can use the property here, that is R1 plus R2. 1 minus 1, 0. 1 plus 1 is 2. This is minus 1 plus 1 is 0. That means two elements are 0. You can easily expand it and you can prove that required result, that is 2 into x plus y into y plus z into z plus x, right? So now, therefore R1 dash is equal to R1 plus R2. Again we are applying the property R1 dash is equal to R1 plus R2 to simplify this determinant. Okay, so therefore D is equal to x plus y into y plus z, right? So what is R1 dash? What is new row 1? 1 minus 1, 0, 1 plus 1, 2, minus 1 plus 1, 0, right? Now what is the second row? Second row remains same, minus 1, 1, 1. Third row remains same, minus y, minus x, then x plus y plus z. Then we write x plus y plus z. Okay? So now we got this determinant. Now we can expand it. Now you can expand it with respect to the first row because there are two elements 0 in the first row. So now let us expand it with respect to the first row. So therefore D is equal to x plus y into y plus z, right? Now let us expand it with respect to the first row. Now what do you write? Plus minus plus plus 0. 0 into any number always 0, don't write it. Then comes minus 2, you have to write it, minus 2 into minus 2, then within bracket. You will consider this term 2, delete the row and the column through the element 2. That means you have to forget about the first row and forget about the second column. Your first row ra your second column se ke bhayo delete bhayeko. First row and second column are deleted. So what remains? Minus 1, 1, minus y, x plus y plus z. पहिला हामी केले केलाई मल्टिप्लाई गर्छौं यो जुन चाहिँ फर्स्ट कलम छ त्यसको माथिल्लो एलिमेन्ट -1 ले यसलाई क्रस मल्टिप्लाई गर्छु. सो कति हुन्छ? -x minus y minus z. So this x plus y plus z is multiplied by minus sign -1. So all the sign will be changed. Okay. Then 1 into minus y, but you have to write minus sign in between the two terms. So minus to minus plus y. So it is plus y, right? Then comes what? Plus 0. Will you write 0? No, because 0 into any number is always 0 in this case. So this is the expansion of this determinant. Okay. Now let us simplify it. Therefore D is equal to x plus y, y plus z into -2 within bracket. So you can cancel y here, plus y minus y gets cancels. So it is minus z minus x. Is that clear? So in this case minus is taken common, right? So therefore D is equal to x plus y into y plus z into, your minus is taken common. So minus to minus plus, that is 2 within bracket. What do we get? It is z plus x. Is that clear? Now you have to write 2 in front of all these terms. That is D is equal to 2 into x plus y, y plus z, and this is z plus x. Is it clear to all of you? So we have proved the result, isn't it? 2 into x plus y into y plus z into z plus x, that is proved. So I think you have understood this question answer, right? So you can copy it. We'll do the next question. That is question number 15. So now we will do this question, that is question number 15. So here n C1, n plus 1 C1, n plus 2 C1 is given. So I think you have done it in class 11, that is NCR. Okay, we have done this type of expression, that is NCR. What does it mean? So this is in the chapter combination, permutation and combination were there in class 11, isn't it? So this is the combination. So what is meant by combination? It is an arrangement. Combination means it is an arrangement, right? So in this case, in how many ways can you arrange these n things taken r at a time? In how many ways can you arrange n things taken r at a time? That is in combination and as well as in permutation was there, isn't it? So what is the formula for NCR? There was a formula for NCR. So its meaning is, in how many ways can you arrange these n things taken r at a time? Okay, this means that arrangement of n things taking r at a time. So this is your from the chapter combination, right? So his formula was, you know about factorial notation, isn't it? That is, this is known as factorial n. Factorial n, how do we define it? 1 into 2 into 3 into 4 into dot 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 into n. That is the product of first n factors. That is starting from n. 1 into 2 into 3 into 4 into dot 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 n. Dot 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 into n. It is defined as what? Factorial n. So its symbol is this one, or you may write n factorial. So in English, this is the exclamation mark, isn't it? So in mathematics, it is the factorial notation. So these two are the same notation. This is factorial n, which is also 1 into 2 into 3 into 4 into dot 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 into n. So this is the factorial notation. Okay. So now what was the formula for NCR? It was factorial m divided by factorial r into factorial n minus r. Now you are in class 12, so you should know the meaning of NCR because we have already done it in class 11, right? So therefore NCR, there is another way of representation of NCR, that is in terms of factors. So how do you write in terms of factors? Starting from n, how many factors will be there? R factors, isn't it? Starting from n, how many factors will be there? R factors. That is starting from n. You write n. Then decrease this n by 1 in the next factor. That is, now n will be decreased by 1. It will be n minus 1, n minus 2, dot dot dot. How many factors are there? R factors. Dot dot dot. What is the Rth factor here? N minus r plus 1 should be there. So Rth factor is n minus r plus 1, but it's not only n minus r. It should be n minus r plus 1 whole divided by factorial r. Okay. So how is it Rth factor is n minus r plus 1? Here first factor is what? Your first factor is equal to n. Now I am explaining you that how did you get that Rth factor as n minus r plus 1? So some may say that it should be n minus r. Some students may say that the last factor is, why is it not n minus r? Why is it n minus r plus 1? You may ask the question like this also, isn't it? So let us prove it. So here what is the first factor? That is n. What is the second factor? What is the second factor is equal to n minus 1. Like it can be written as n minus 0 is there, isn't it? This is n minus 0 is equal to, how will you write it here? N minus 0 is there, isn't it? So n minus 1 minus 1. So 0 is written as 1 minus 1, right? Similarly, what is the second factor? N minus 1. Since first factor 1 is there, you should write 1 here. This is minus 1. Okay? Now is equal to n minus within bracket. How will you write down this one? So since there is 2 here, so 2 minus 1. This minus 1 remains fixed here. It is constant. Change the then here. Sir? That's about the third factor. What is the third factor? N minus 2, isn't it? And third factor is n minus 2. So it is n minus, how will you write down? How will you write down these two? 3 minus 1. 3 minus 1, right? So this minus 1, minus 1, minus 1 remains same. Here also n remains same. Only this number changes, 1, 2, 3 like that. Okay? So this is the nth factor, isn't it? That is your, which factor is this one? Nth factor. So nth factor is equal to, how do you write it? Nth factor is equal to n minus, so within bracket, not this nth factor, this is rth factor, sorry. This should be the rth factor, not nth factor. This is the rth factor. This is your what? Rth factor. Okay? So since there is third factor here, third factor, if it is 3, then this should be n minus 3 minus 1, right? But if it is rth factor, what will you write? This n remains same, minus within bracket. If there is first factor, it is 1. If there is second factor, there is 2. If it is this is third factor, this is 3. If this is rth factor, you should write r minus 1. Is that clear? So I think you have understood it. How the rth factor is n minus r plus 1. So starting from n, how many factors should be there? R factors. So this is the rth factor. So it is n minus within bracket r minus 1. So if you open this bracket, I mean bracket Kurseong, the bracket called n minus r plus 1. So this is your rth factor. Is it clear to all of you? So you have to remember both this formula. We can use this formula while simplifying, right? We can use this factors formula while simplifying this determinant. Okay? So now, suppose if you have NC1, what is meant by it? Starting from n, how many factors should be there? One factor. Starting from n, there should be only one factor, divided by factorial 1. So factorial 1 means 1, you know that, which is equal to n. Similarly, what is NC2? How will you write NC2? Starting from n, how many factors should be there? 2 factors. That is, first factor is n. What is the second factor? 1 is, you n bada 1 less ganu, that is n minus 1 divided by factorial 2. That is the formula, isn't it? So which is equal to n into n minus 1 divided by, what is factorial 2? That is factorial 2 means 2 into 1, like this. Okay? Suppose if you have 5c2, how can you simplify it? 5c2, it is 5 into 4, that means starting from 5, how many factors will be there? 2 factors, 5 and 1 less than 5. There is 5 minus 1, which is equal to 4. So 5 banda say 1 less 1. Next factor that is 4 divided by factorial 2. What is factorial 2? It is 2 into 1, which is equal to 5 into 4 divided by 2 into 1, right? So 2 1s are 2, 2 2s are 4, which is equal to 5 2s are 10. So that is the simplified form of 5c2. So is it understood now, NCR? So I'm just revising it because we need all this concept in this determinant. Okay? So I think you have done it in class 11. तिमीले class 11 मा यो NCR गरिसकेको छौ हैन? So म just एउटा रिभिजन मात्रै गरेको यो. ठीक छ? र अब now let's simplify this determinant. So now D is equal to, now this is your left hand side. Let us write down the first column 1. What is NC1? Starting from n, how many factors should be there? Only one factor. That means n divided by factorial 1, isn't it? NC1 means starting from n, there should be only one factor. Like NC1 is equal to, starting from n, there should be only one factor, that is n. Divided by 1 is there, this is factorial 1. Which is equal to factorial 1, भनेको कति हो? 1 नै हो. So n upon 1 is always n. So this is n, right? Next, what is n plus 1 C2? N plus 1 C2, what does it mean? Starting from n plus 1, you should write the starting term as n plus 1. Starting from n plus 1, how many factors should be there? 2 factors. That is, first factor is n plus 1. त्यहाँदेखि के गर्नु पर्यो 1 लेस गर्नु पर्यो n plus 1 बाट. So 1 लेस गर्दा n plus 1 बाट कति भयो n divided by factorial 2. What is meant by factorial 2? 2 into 1. So which is equal to n plus 1 into n divided by factorial 2 is 2. Right? So instead of n plus 1 C2, what will you write? N plus 1 into n by 2. So it is n plus 1 into n by 2. Is it clear? So next one, what will you do? Next is 1. So you should write 1. So now here n plus 1 is there. N plus 1 C1 means starting from n plus 1 there should be only one factor. That means what will you write? N plus 1 only divided by factorial 1. So what is it? N plus 1, right? So this is your n plus 1 only. Now similarly, what is n plus 2 C2? Now n plus 2 C2 is there. So what is meant by it? Starting from n plus 2, how many factors? 2 factors. So one of the factor is n plus 2. What is the other factor? 1 less गर्नु n plus 2 बाट. कति हुन्छ? n plus 1. 1 less. n plus 2 बाट 1 less गर्दा कति भयो? n plus 1. So what do we write here? The starting factor is n plus 2. Then 1 less. 1 less गर्दा कति भयो? n plus 1 whole divided by. There is 2. Factorial 2. What is factorial 2? It is 2. Is that right? So next. Again, the third column. What is the third column now? 1. Next. What is n plus 2 C1? So starting from n plus 2, there should be only one factor. I mean n plus 2 बाट start गर्छौ एउटै factor मात्रै लेख्छौ. That means n plus 2 मात्रै भइगयो. So this is n plus 2 divided by factorial 1, isn't it? So what is factorial 1? That is 1. The denominator ma 1 भयो भने हामी त्यो लेख्दैनौ. So next, what is the next one? n plus 3 C2. Now starting from n plus 3, there should be 2 factors. So which is the starting factor here? N plus 3. Then you have to write down the 2 factors. So one is n plus 3. One is n plus 3. What is the other factor? You have to subtract 1. You have to subtract 1 from n plus 3. That is the second factor. 1 less गर्नु n plus 3 बाट. So 1 less गर्दा n plus 3 बाट कति भयो? n plus 2 divided by what? Factorial 2. Right? What is factorial 2? 2 into 1. That is 2 only. That is, this is 2. So we got this determinant, right? So now there are 3 ones in the first row. You can make any 2 of these ones 0 by using properties here. That is C2 minus C1. You may write C1 minus C2. Let's do C2 minus C1. So column 2 is changing. Then again C3 minus C2. Here also column 3 is changing. Let's use this property now. C2 dash is equal to C2 minus C1 and C3 dash is equal to C3 minus C2. Right? So what is D now? D is equal to first column remains same. 1 n plus 1 n by 2. Right? Now what is the... This is the first column, remains same. Now what is the new second column? C2 minus C1. 1 minus 1 is 0. This minus this, n plus 1 minus n, that is 1. And this minus this. Yo minus yo. गर्दा कति कमन आयो र त? This minus this गर्दा n plus 1 by 2 is taken common. N plus 1 by 2 is taken common from these two terms, isn't it? So n plus 2 into n plus 1 by 2 minus n plus 1 into n by 2. So what is common out here? N plus 1 by 2 is taken common here. So within bracket, what do we get? That is n plus 2 minus this n. Minus n. Is that clear now? We have just simplified this minus this. So we get n plus 1 by 2 as common. So within bracket, the remaining terms are n plus 2 minus n. Clear? So next, what is the new third column? C3 minus C2. that is 0. N plus 2 minus n minus 1, n gets cancelled. What is 2 minus 1? That is 1. Again C3 minus C2. Again this minus this. What is common? Again here n plus 2 by 2 is common. N plus 2 by 2 is common, right? So within bracket what do we get? This minus this. So n plus 2 by 2. N plus 2 by 2 is taken common here. So within bracket what do we write? N plus 3, then minus n minus 1. Minus n minus 1. So this is the third column. So I think you have understood it. Is there any problem? So we got this result. Okay. So now next. Therefore D is equal to, now what is the first column? 1 n plus 1 into n by 2. This is 0, 1. How much is that? This n gets cancels, and in the next step this 2 also gets cancelled. What do we get? It is n plus 1, right? So now next, what is the third column? It is 0, 1. Here also n gets cancels, right? What is 3 minus 1? 2. So in the next step this 2 also gets cancelled. So we get only n plus 2 here. So this is the simplified form of the determinant. Clear? So now we can easily expand it, and you can prove this is equal to 1, right? So let us expand it now. So now let us expand it. Therefore D is equal to, we can expand it with respect to the first row, that is 1, 0, 0, because there are 2 zeros in the first row. So what is the method now? Plus 1 minus 0 plus 0. So you take first plus 1 within bracket. Now delete the row and the column through this element. Forget about the row and the column through the element. Delete the row and the column through the element, that is first row and first column are deleted. What remain? 1, 1, n plus 1, n plus 2. Now cross multiply by 1 into n plus 2, n plus 2. Bisma ke sana minus. Then 1 into n plus 1 is n plus 1. But because of this minus, here the sign changes. That is 1 into n plus 1 is n plus 1. So minus n minus 1. Is that clear? So therefore D is equal to, here n gets cancels. So it is 1 into, what is 2 minus 1? That is also 1. That means D is equal to, what is the answer? 1 ones are 1. So which is equal to right hand side, which is equal to 1. So your question पनि तिमीको HS मा आएको थियो नि ल, यो पनि HS बाटै दिएको ठीक छ. So this question is very important, so you can copy it, try to understand it. Okay, so we'll do the next question now, that is number 16. Now we will do question number 17. So 17 is also very important, right? Here you have to prove this determinant, that is y plus z, z plus x, x plus y first row, z plus x, x plus y, y plus z second row, and third row is x plus y, y plus z, and z plus x is equal to 2. There are single elements out here. That is 2 into, in the first row only x, y, z are there. In the second row y, z, x. In the third row z, x, z, x, y. Again is equal to, you have to prove minus 2 into within bracket x cube plus y cube plus z cube minus 3x, y, z. That is, you have to prove first is equal to second is equal to third. Okay. So now let us prove first is equal to second. So what is D now? D is equal to, that is your left hand side, y plus z, z plus x, x plus y, right? So you have to write it. This is the left hand side, z plus x, x plus y, y plus z, and then next one is x plus y, y plus z, and this is your z plus x. So now, which property will we use to simplify it now? So if you do R1 plus R2 plus R3, right? If you do R1 plus R2 plus R3, let's see what happens. X plus X 2X, Y plus Y 2Y plus 2Z. 2X plus 2Y plus 2Z, that is 2 is taken common here. These are also added. X plus X 2X, Y plus Y 2Y, Z plus Z 2Z. So this is also 2 is common there. So within bracket X plus Y plus Z. Okay. In the third column also X plus X 2X, Y plus Y 2Y, Z plus Z 2Z. So 2 is taken common here. So within bracket X plus Y plus Z. Okay. You can do C1 plus C2 plus C3 also. So column 1 it says you will get the same elements in the first column as in the rows. That is, in the first column all the elements will be 2 is taken common, X plus Y plus Z. That is your common term in the first column. So let us use the property in column, right? So C1 dash is equal to C1 plus C2 plus C3, right? So what is D now? What is D? Now column 1 is changing. How does it change? C1 plus C2 plus C3, right? This plus this plus this. What is it? 2x plus 2y plus 2z. What is common there? 2. 2 within bracket x plus y plus z, right? Here also, what is the second element of the first column? Again, x plus x 2x, y plus y 2y, z plus z 2z. That is 2 is taken common here. X plus y plus z, right? And the next one is, what is the next one? All the elements of the third row are added. X plus x 2x, y plus y 2y, z plus z 2z. Here also 2 is taken common. X plus y plus z. Here, so this is the new first column. So second column remains same. What is the second column? Z plus x, x plus y, and y plus z, right? Third column, x plus y, y plus z, and z plus x. Is that clear? So now what will you do in the next step? You have to take common. What is that common? Don't take 2 into x plus y plus z as common, because in the second determinant, which is to be proved, x plus y plus z is not taken common out here. Only you have to take 2 as common. So what is D now? D is equal to only 2 is taken common from the first column. Okay. So what is the new first column now? It is x plus y plus z. This is also x plus y plus z. Third element of the first column is also x plus y plus z. Now write on the second column. What is the second column? Z plus x, x plus y, y plus z. Y plus z, right? And what is the third column? Third column also remains same. That is x plus y. Next, y plus z, y plus z. And what is the next one? It is z plus x. It is z plus x. Is that clear now? So now what will you do in the next step? So now, यहाँ प्रत्येक टर्ममा एक-एकवटा मात्रै एलिमेन्ट छ. अब यसलाई एक-एकवटा एलिमेन्टमा चेन्ज गर्ने. बुझ्यो? त कसरी चेन्ज गर्ने त एक-एकवटा एलिमेन्टमा? Now, if you do C2 minus C1, if you do C2 minus C1, let's see what happens. Z plus x minus z minus x, cancelling minus y. Only one term is there. Here also x plus y minus x minus y gets cancelled, minus z. Here also y plus z minus y minus z gets cancelled, minus x. Only one term are there in the second column, right? Similarly, C3 minus C1 should be there. You should do C3 minus C1. Then only you get one term here. एक-एकवटा term also here, third column. X plus y minus x minus y, that is minus z. Y plus z cancels, minus x. Z plus x gets cancelled, you get minus y here. Okay, so let's use the property. C2 dash is equal to C2 minus C1, and C3 dash is equal to what? C3 minus C1, right? So that we can get single elements in the second column and in the third column, right? So D is equal to, now here first column is not changing, remains same. So you have to write 2 first, write on 2 first, then write on the first column x plus y plus z, x plus y plus z. This is also x plus y plus z, right? Now what is C2 minus C1? This minus this, z plus x minus z minus x gets cancels. You will get minus y. This minus this, x plus y minus x minus y gets cancels, minus z, right? Next, y plus z minus y minus z gets cancels, minus x only, minus x is there now. It is only minus x is there, okay? Next, C3 dash is equal to C3 minus C1. What is C3 minus C1? X plus y minus x minus y minus z is there. Then again, y plus z minus y minus z gets cancels, minus x. Next one, z plus x minus z minus x gets cancelled, then minus y. So there are single elements in the second column as well as in the third column, right? So again you have to simplify the first column now. In the first column also, each and every element are single here, isn't it? That is x, y, z. एक एक वटा मात्रै छ. अब यसलाई पनि एक एक वटा मात्रै बनाउनु पर्छ. So how can you make it? C1 plus C2 plus C3. Y minus y, z minus z cancel, you get only x. Similarly here, similarly here, z, z and x gets cancelled, you get only y here. And in the third row, x, x cancel it, y cancel it, you get only z. So what is the property that you can use here? C1 dash is equal to what? C1 dash is equal to C1 plus. So now, you x plus y plus z, x plus y plus z, or x plus y plus z लाई पनि यसलाई हामी single elements बनाउँछौं. Because there is x, y, z is there. So what will you do here is C1 dash is equal to C1 plus C2 plus C3. If you do C1 dash is equal to C1 plus C2 plus C3, then look at the blackboard. Y gets cancelled, Z gets cancelled, you will get only x. Here also Z gets cancels, X cancelled, you get only y. Here x and y gets cancelled, you will get only z. So what will you do here is C1 dash is equal to C1 plus C2 plus C3. What is D is equal to now? 2. Now let's do C1 plus C2 plus C3. This plus this plus this. Y and z will be cancelled. So only x is there. Similarly, C1 plus C2 plus C3 in the second row. X and z will be cancelled. You will get only y. Similarly, third row. All the elements of the third row are added. You can cancel x and y. What do we get? Only z. So second column and the third column remain same. So it is minus y, minus z, minus x, then minus z, minus x, and this is minus y. Is that clear now? So now, what will you do now? You can take minus common from the second column and from the third column. Your second column and third column बाट अब हामी कति common निकाल्छौं? Minus sign common निकाल्छौं. So therefore D is equal to minus sign is taken common from the second column. Again minus sign is taken common from the third column. Okay. This minus sign is taken common from the second column, and again into this minus sign is taken common from the third column. Right. So minus into minus plus. So 2. So now it is x, y, z. In the first column, so it is yzx, yzx in the second column, and in the third column, zxy. In the third column, it is zxy. Is it clear now? So minus to minus is plus. So D is equal to 2. So it is, what is the first row? xyz. What is the second row? yzx. What is the third row? It is zxy. So it is proved. Right? So it is 2 xyz, yzs and zxy. So it is proved. Now we will prove this is equal to this expression, that is minus 2 into x cube plus y cube plus z cube minus 3xyz. That is, this second is equal to third, right? So let's prove it now. Now let's prove this second is equal to third. We can directly expand it, okay? So therefore d is equal to twice. Let us expand it with respect to the first row. First row means plus x, write down x within bracket, delete the row and the column through the element. So it is z into y z, b sum minus sign, x into x square, bracket closed. Then comes minus y, isn't it? Then according to the rule you have to write minus y. So y is there, delete the row and the column through the element. So it is y x z y. So y into y square minus zx. Y square minus zx, right? Then write down, it is y square minus zx. Then you have to write, this is your z. So it is plus z. Plus minus plus, right? So plus z, if you consider this element z, delete the row and the column through the element, that is first row and third column are deleted. What remains? Y, z, zx. Now cross multiply by y here. So it is xy minus z square. So your third bracket is closed, right? So now let us expand it. So d is equal to twice within bracket x y z minus x cube minus y cube plus x y z, right? Then plus z into x y z. So plus and minus minus, this is your z cube, right? Or d is equal to twice within bracket. Let us write down minus x cube first, then write down minus y cube, then minus z cube. Now we can add all these three similar terms. What is it? What is the summation? Plus 3xyz. Now take minus common here. Therefore d is equal to minus 2 within bracket x cube plus y cube plus z cube. So this is minus 3xyz, which is equal to extreme right hand side. That is, we have proved first is equal to second is equal to third. So proved. Is that clear? So sometimes you may be asked to prove this first is equal to third. First is equal to third, but you will not get this second determinant. Okay? But you will not get this second determinant. So in that case also, you have to derive this second determinant and then prove this result. Okay? So, first is equal to third मात्रै पनि दिनु सक्छ. त्यतिबेला तिमीले यो चाहिँ निकाल्नै पर्छ. यो निकालेपछि मात्रै यो प्रुभ गर्नु. That is the easiest way to prove first is equal to third. Is that clear? So now you can copy it. We'll do the next question. Now we will do question number 20. So the question number 20 is, if A, B and C are in AB, you have to show that this determinant, that is x plus 1, x plus 2, x plus A are in the first row, x plus 2, x plus 3, x plus B are in the second row, x plus 3, x plus 4, x plus C are in the third row. That this determinant is equal to 0 if A, B, C are in AB. You know AP, isn't it? You have done it in class 11 also. AP means arithmetic progression. If these three numbers are in AP, then what can you write? Second term minus first term is equal to third term minus second term. That is, what is an AP? A series of quantities are said to be in AP if the algebraic difference between the succeeding and the preceding term is the same throughout the series. That is, second term minus first term is equal to third term minus second term. Is that clear? So what is an AP? a series of quantities are said to be in AP if the algebraic difference between the succeeding and the preceding term is the same throughout the series. That means second term minus first term is equal to third term minus second term is equal to fourth term minus third term is equal to fifth term minus fourth term, and so on, right? All these difference are known as the common difference. Okay, so what can I write here? If A, B, C are in AP, then what can we write? B minus A is equal to C minus B. Is that clear? That is second term minus first term is equal to third term minus second term. Their difference is same. That is known as the common difference in case of arithmetic progression. Okay. So now let us write down this D. D is equal to left hand side. What is D here? X plus 1, X plus 2, X plus A, right? X plus 2, X plus 3, X plus B. Then X plus 3, X plus 4 and X plus C. So now, how can you make this determinant easier? You have to use the property here also. You have to use the property in such a way that you should get either B minus A or C minus B. So that instead of B minus A, you can write C minus B, or it may be instead of C minus B, you can write B minus A. So how can you make it B minus A? That is, here R2 minus R1, isn't it? This is X is cancelled, B minus A. Then comes R3 minus R2. This also X is cancelled, we get C minus B. That means we are using the property here, R2 dash is equal to R2 minus R1 and R3 dash is equal to R3 minus R2. Is that clear? Now let us write down R2 dash is equal to R2 minus R1. That means row 1 is changing, and R3 dash is equal to R3 minus R2, right? R3 minus R2. Is that clear to all of you? That is R2 dash is equal to, you have to write R2 minus R1 and R3 dash is equal to R3 minus R2. That means row 2 and row 3 are changing, but not R1. Okay? So R1 remains same. So D is equal to, now let us write the first row. First row remains same. X plus 1, X plus 2, then comes X plus A, right? Next, X plus 2, then X plus 3, then X plus, you have to subtract it. That is R2 minus R1, isn't it? You have to subtract R1 from R2 minus R1. This minus this, X plus 2 minus X minus 1, X gets cancels, 2 minus 1 is 1 here, right? Similarly, X plus 3 minus X cancels, 3 minus 2 is 1. And this one, X plus B minus X cancels, B minus A. This is your B minus A, right? This is the new second row. Now, what is the new third row now? What is the new third row? R3 minus R2. So how does it change? R3 minus R2, right? This minus this, X plus 3 minus X minus 2. 3 minus 2 is 1. This is also X plus 4 minus X minus 3. This is also 1. X cancel it. Then again X plus C minus X minus X cancel, C minus B. So this is your C minus B. Is it clear now? Next, what is the condition given here? If A, B, C are in AP, then B minus A is equal to C minus B, or C minus B is equal to B minus A. So instead of B minus A, you can write C minus B, or instead of C minus B, you can write B minus A. Let us write C minus B instead of B minus A, right? So therefore, D is equal to X plus 1, X plus 2, X plus A. Remains same, first row. 1, 1. Now instead of B minus A, what is the value for B minus A here? C minus B. Let us write C minus B. And third row remains same. Okay? 1, 1. This is C minus B. Okay? So now, what can you say about this determinant? Two rows are identical. So what is the value of this determinant? It is 0 from the properties of determinant. That is the third property. So what is third property? If two rows or two columns of a given determinant are identical, then the value of the determinant is 0. The property number 3 case are, if two rows or two columns of a given determinant be identical, then the value of the determinant is always 0. That means here D is equal to 0. Proved. So we can write here, since two rows are identical. Since two rows are identical. So this is the answer. Is that clear to all of you? Now I'll give you the homework. You can try it at home. Okay? Now this will be your homework. That is, you have to prove that 16, 18 and question number 19. You have to prove it. Okay. So this is your homework. This is your homework from the exercise 2B. Each question carries 5 marks. Determinant, page number 176. So question number 16 is 1, 1, 1, sin alpha, sin beta, sin gamma, cos alpha, cos beta, cos gamma is equal to, you have to prove this result. So you can make any two of these ones 0. You can make any two of these ones 0 by using the property C1 dash is equal to C1 minus C2 and C2 dash is equal to C2 minus C3. Then you have to use the formula from trigonometry, right? So you can do it. So this one, number 18, you have to prove this is equal to that. Left hand side is equal to right hand side. So you just write down this left hand side and then expand it with respect to the third row, because there is one element at 0 here. Okay, so expand it with respect to the third row directly. Don't use the properties of determinant here. Okay, so expand it with respect to the third row because there is one element at 0. Plus, minus, plus, like that. Okay, you can do it. Okay, then you have to use the formula from trigonometry. So here also in number 19, you have to prove that 0 cos alpha minus sin alpha 0 cos alpha sin alpha 0, this determinant plus whole square is equal to, first row 1x minus x, second row x1 x, what is the third row? Minus x x1, where x is equal to sin alpha cos alpha. So what you will do here is, you just write down the left hand side, d is equal to left hand side, then whole square means you have to write down the multiplication of two same determinants. Like if there is a square, you should write a into a. But if this determinant whole square is there, you should write this determinant into this determinant. That is 0 cos alpha minus sin alpha 0 cos alpha sin alpha 0. This determinant into, what is the other determinant? Same determinant is there. That is, you have to write it twice into determinant 0 cos alpha minus alpha sin alpha 0 cos alpha sin alpha 0. So you can multiply these two determinant. You know how to multiply the two determinant. You do row by column or row by row. So you can get, you may get this answer. But if you get sin alpha into cos alpha, instead of that sin alpha cos alpha, you should write x. यदि तिमीले त्यो सिम्प्लिफाई गर्दा रो बाइ कलम गर्दाखेरि यदि तिमीले sin alpha cos alpha कुनै टर्म आयो भने चाहिँ what can you write instead of that sin alpha cos alpha? You should write x. Is that clear to all of you? So these are your homework. Okay, that is 16, 18 and 19. Okay, so this much is for today. So you can revise all the problems that we have done so far. Okay, so in the next class we'll do more problems. Okay, thank you.